For section 3.5, we're going to be looking at domain and range and how to identify domain and range given certain functions. Now, as you've learned in the past, domain is any input value. In other words, domain is what you're going to put into the function. In most cases, it's the x's. Range is the output value, or what comes out of a function. In this case, it's the y's. So domain is the x's, range is the y's, or the output values. Domain and range are both listed from least to greatest, and we don't repeat any numbers. So when you're listing your domain and range, if you have multiple numbers, do not repeat it. You also need to list those from least to greatest. Let's look at an example. So let's say that I've given you this function, the function with the 0.23, -4.3, and -4.8, and I ask you to list domain and range. Well, let's start with domain. For domain, you put a capital D and an equal sign, and then you open it with a brace. Remember, a brace is how we represent multiple numbers. So since there's multiple numbers in the domain, we need to list it using a brace. Domain is the x's, and for my x's, I've got a 2, a -4, and a -4. We want to list this least to greatest. We don't want to repeat. So I'm only going to write that -4 once, even though there's two of them, and then I'm going to write the +2. So what I've done is I've listed them least to greatest and I have not repeated. Now let's look at range. Range, we're going to do exactly the same way. Capital R, open your brace, since we've got multiple numbers. Range is the y's. It looks like I've got a 3, a 3, and an 8. Once again, I'm not going to repeat that 3. I'm just going to write it once, and then I'm going to write my 8. So this is my domain and range of this function. Now let's look at finding domain and range from a graph. When you've got to find domain and range from a graph, you're still going to be looking at your x's and y's, but the way that we're going to do this is we're going to write this in interval notation. So when you do domain and range from a graph, you're going to use your interval notation rules. Let's go ahead and look at domain first. So for domain, we put a capital D and an equal, just like on the last one. And domain is the x's. So here is my x-axis, and I need to look at where this function is crossing the x-axis. Well, it looks like this function goes from this x all the way to this x. So I need to list all the numbers from this x to this x. Well, this happens to be -1, 2, 3, 4, 5, 6. This happens to be -6. This happens to be +6. So it looks like my domain is going from -6 to +6. Now, since it is actually touching that 6, -6 and +6, I'm going to use a bracket. So it'll look like this. You're saying, when you write this, you're saying x is from -6, and the bracket says it can be -6, all the way to +6, bracket, it can be a +6. In other words, it's touching the +6. Now let's look at range. Range, once again, is our y values. So now we're going to be looking at our y-axis. In other words, how far down and up is our graph going? Well, if we go ahead and put our marks, it's going from here to here. Looks like it's going -10 to +9. Remember, we want to go least to greatest. So it's going from -10 to +9. The way that I want you guys to think about this is domain is going to be how far left to how far right, just like we would do interval notation. Range is going to be how far down to how far up, just like we would do interval notation, except you're looking at a graph this time. All right, let's go ahead and look at another graph. For this graph, we're going to go ahead and do domain and range again, and we're going to write it in interval notation. Now remember, for domain we're telling how far left to how far right. So let's look at this graph. Domain is x's, or left to right. So here's my x-axis. Looks like my x's are from here to here. Now, this is where this is tricky. For this one, it's not just where it crosses. If you look at this parabola is going to extend on and on and on and on and on to the left forever, on and on and on and on and on to the right forever. And what makes this tricky is it makes this domain -infinity to +infinity. In the last graph, it actually stopped and started at these intercepts. In this graph, if you're looking at how far left to how far right, this graph will go on and on and on forever in the left direction, and it'll go on and on and on forever in the right-hand direction. And so that's why it's -infinity to +infinity. Now let's look at range. Remember, range is how far down to how far up. So if we're looking at this graph, the lowest point it's going to get is down there at -9, and it actually is touching that -9, so I'm going to put a bracket. How far up is this graph going to go? Well, honestly, if I'm looking at the graph, it's going to go up forever on both sides, which means it's going to go up all the way to +infinity. How far down to how far up? How far left to how far right? For our last new item today. I want to talk about function notation. You've seen function notation before. This shouldn't be a surprise. This is just a review. If I give you a function written f of x equals 9x minus 5, and I ask you for f of 2, when I say f of 2, I'm telling you the domain, or the x, is 2. What's the range? So when you plug in the 2, what comes out? Remember, 2 is your input, range is your output. So if I plug in the 2, what's going to come out? Now I want you guys to be careful here. This f of x means nothing more than y, or range. You're not actually going to plug that 2 into that x. You're actually just going to go ahead and plug the 2 into this x only. 9 times 2 is 18. 18 minus 5 is 13. When I plug in a 2, 13 is my output value, or my range. In other words, the point 213 satisfies this equation. Now you could answer this one of two ways. You could literally just answer a 13, or you could be really fancy and you could answer 213. Either one of those would be acceptable answers, but the 13 is what I'm going to be looking for. Now let's look at number 2 down here. This is a little bit more complicated. I want to know f of a plus 2. In other words, I want to know when you plug in an a plus 2 for your x, what's the output value? Now remember, we're not actually plugging it in for that f of x. All that means is y. So we're plugging it in for this x. So instead of x minus 2, it's a plus 2 minus 2. And then we got to simplify this. We've got to put our numbers together. Positive 2 minus 2, y is a. You can answer it that way, or you could be really fancy and you could say a plus 2 is my input, a is my output. Remember, either one of these would be acceptable answers to me. And what I'm going to be grading is that y value, or that output value.